How'd you look? Herb? Okay. So today we're going to be doing a paper lab to hopefully help y'all to get a little better understanding on ionic compounds and their formulas, because between ionic and covalent's easy, and so I don't focus a lot on covalent. All you end up doing is just counting atoms and using prefixes. But ionic, you have to balance out your charges. And so what this is designed to do, it's designed to let you have a little more hands-on for something that's usually not very hands-on at all. Okay, and make it more than just letters and numbers on paper. If you are doing this at home, then the assignment right here's got 3 attachments to it. The first one I'm going to take a look at is the paper that all of you have here in your hands, and that's just the instructions on the front page. And then, if I can shrink that down a bit. And then there's a data table on the back page. If you are having to do this at home, then you're going to need to print out a set of these cards, and then you're going to need to read the instructions I left and color code them how it tells you to color code them. But for everybody else here, let me show you something real quick. Okay, so what I've got is I've got some different cards here, and for instance, I'm going to pull out an aluminum card, and I'm going to pull out a chlorine card. Now, looking at those two, y'all make some observations. How are they similar and how are they different?
It has a 2 plus. 2 plus. One negative takes off one, so it has 2 left.
Okay, so they're different because they've got different charges, right? Okay, so this one's got positive charges on it. The one over here's got negative charges on it. How else are they different?
One is a metal, one is a non-metal.
One's a metal and one's a non-metal. Very good. Okay. And if you've been paying attention at all, when we have metal and non-metal atoms bonding, they do so through ionic bonds. Okay. Whether or not there is a thing such as ionic bonds, we're not going to argue about. We're just going to call them ionic bonds for right now. So if I was going to stick this and this together and make a compound out of it, would that do it? Yes or no?
No.
Why not?
There's three aluminums and only one chlorine.
Actually, there's only one aluminum and only one chlorine.
That one has 3 charges.
It does have 3 positive charges, so why don't it work?
Because the number of charges is not the same.
The number of charges is not the same, thank you. So how could I fix that? How could I make the number of charges the same? Add a couple more chlorines? Okay, cool. I'm game. So, are you happy now?
Yes.
Okay. And that's good. So, how many aluminum atoms do I have here? I have 1, because 1 card is 1 atom. It's 1 ion. Okay. How many chlorine atoms or chlorine ions do I have?
3.
3. So, what would the formula for this be?
AlCl3.
Al1, right? Cl3. All right, very good. So do y'all see that? There's not a number there, which tells us that there's kind of an understood number 1 that you don't have to write. And there's a 3 here, which tells us, hey, I've got 3 cards. 1, 2, 3. Everybody cool with that? All right. What would the name of this compound be? Good question, right? Don't make it harder than you think it is. Say it again. Aluminum chloride is totally right. Because when you're naming ionic compounds, you write the name of the positive ion, you write the name of the negative ion. Okay? Let's look at something else. What if I had a situation like, let's take this one, and let's take this one here. Okay, magnesium and hydroxide. What do I need to do?
Yeah, another.
Okay, I'm gonna put another hydroxide on there. Okay, so all my positives, all my negatives are balanced. How many magnesiums do I have? I have one. Okay, and how many hydroxides? Two. How would I write this formula? Okay, so is this right here?
No, you gotta put parentheses on OH.
I gotta put parentheses on OH. Now I bring this particular example up because for some reason people always forget that OH is a polyatomic. That if you're gonna have more than one of them, you've got to put parentheses around that OH and put the 2 on the outside. And that's gonna hold true for any polyatomics. So what would the name of this be?
Magnesium oxide.
You're close.
Magnesium hydroxide.
Magnesium hydroxide. Okay. So, this is a great place for questions, any at all. Because if this is making sense to you, then you're going to be in good shape to do the lab activity today. So let me pull up the instructions real quick one more time. Okay. So it's going to give you instructions on the front here. I do want to point out that there's also some questions on the front. There's questions A, B, C, and D that as you work through it or start to work through it, do exactly what it says and answer those questions as you go. But then you're going to follow your directions. You're going to build what it tells you to build. And then you're going to put the data back here on the data table. Okay? I'm going to popsicle stick you into groups of 2 and 1 group of 3 toward the end because y'all are a big class and an odd number. But you have got today to work on this. I'm also going to give you time tomorrow to work on this if you need it, in addition to anything else that you might still owe me at that point. So do not rush through this. Make really good and sure that you know what you're doing. And if you get put with a partner who's just writing stuff down and says, hey, write this down, don't take that. The point of this is for you to increase your understanding. So if you're not sure why they're writing something down, challenge them. Say, why'd you put that? And if they can't explain it, they probably don't know either. Okay? So, before I put you in groups, does anyone have any questions? Okay.